Hey guys, Dan with Sequence Engineering, and today we're going to cover a few of Victron's newest products and how you may use them in a system that you're currently designing or a system that you're looking at for future applications. Victron has launched several new products that are going to make it easier for us to operate at higher voltages and also make it safer for us to operate at higher voltages. So at Sequence, we spend a lot of our time working on commercial applications where the client may want to operate at 24 or 48 volts, and they also want to use very large lithium iron phosphate battery banks. And in doing that, there's always been a need for a Class T fuse in the system in order to achieve the fusing that we need at those higher voltages and also at that higher AIC rating, right? And so Victron has actually recently launched the Class T Powerin, which has now given us the ability to do that in the Victron infrastructure. And so I just wanted to spend a few minutes covering this product for you, why it matters, and how you might use it in a system that you're designing. So what you'll see here is that the Class T Powerin looks very similar to the old Lynx distributor or Powerins that you're used to seeing. The main variance here is, as you'll see when I pull the cover, is that there are only two locations for Class T fuses. Okay, you have here and here. Now, this device works identical to the old Lynx distributor. The only thing missing from it is there are no circuits in it. There is nothing that is actually communicating data back to your BMS or some other device in the system. But it does give you the ability to fuse either your battery in, or you can use this as a distributor and fuse your outputs to your DC system. Let's say an inverter or a charger or something else. We like to use these in 48 volt systems in this exact configuration where we will actually pull the batteries into the system over here. And then we will actually feed, let's say, a Quattro or a Multiplus off of one of these legs here. One thing to note as you design and use the Class T, or the Lynx Class T Powerin, is that this bolt hole spacing here is specifically designed to operate inside of the Class T fuse that is 225 amps up to 400 amps. So you must purchase a Class T that is in that size range. Here is an example of a 200 amp, and you will notice that it is too small to fit across those bolt locations. So that one will not work. You would actually need the larger size, right, which is, let's say, like a 300. You see the size difference in the bolt hole spacing difference. That one will fit in there just right. So as you design and size these for your systems, just keep in mind that you can only drop down to a 225 amp fuse, and you can only go up to a 400 amp fuse. So that is the basics of the Lynx Class T Powerin. Very helpful device. It's going to allow us to operate within ABYC standards and also give us the nice clean look that we're used to operating with the Victron infrastructure. Now, the next product that we're going to take a look at is the Lynx Smart BMS. Now, you will notice that this is the new version of the Lynx Smart BMS. As you see here, there is an indication that it is different than the older version because it has this orange NG here on the face. And the other thing that you should note is that it says M10 right here. It is critical to note that that M10 is actually the bolt hole size that is used for this device, and these cannot be used with the older historical version of the Lynx distributor that is M8 or the old Powerin that is also M8. All right, so you must pair this device with things that operate in the M10 infrastructure, right? So this Class T Powerin is M10. They also offer Powerins in M10 as well as Lynx distributors in M10. Now, you're probably asking yourself, why would I want to use the new NG BMS versus the older version? And the primary reason that you would want to go with the newer version of the BMS is that it is far more advanced in terms of how it is communicating with the battery itself, and also how it's going to communicate with other BMSs in the system. Now that they have moved to the NG battery line and the NG line of BMSs, what you gain is you gain digital data from the battery. So the previous generation of batteries communicated in a pure analog signal. Now we're communicating in zeros and ones, where this is actually seeing a lot more data from the battery. So over the M8 cables, right, coming out of the bottom of the device and connected to the battery, it is now actually looking at each individual cell, and it is also looking at battery temp, and it is looking at everything else that you would want to know in order to determine the health of that battery, and it is feeding it back to the BMS. So what does that mean for us as installers and system designers is that we can now see data that we could not see historically remotely. So I can log into VRM and I can actually look at each individual cell in that battery to see exactly what's going on and how that battery is performing. In addition to that, I can also determine if there are any error codes or any other issues with the battery. I could adjust the voltage where it is allowed to discharge, right? And I could also update the firmware remotely, which is something that we could not do previously. So a big upgrade in terms of how the BMS actually communicates with the battery. So exciting stuff there. Beyond that, this device is going to function very similarly to the historical version that we're used to, right? Inside of here, there is a contactor, which we are used to seeing, right? That is designed to prevent power from going from here to here, okay? And in the event that the BMS sees something that it doesn't like, it is going to open that contactor. This is also a shunt, so it is measuring the amount of power going from one side to the other, right, to keep it in simple terms. And that is what is actually providing us with this percent of charge number down here. So it is literally doing math to determine how much power is going from point A to point B, and over time, it will run its calculation to give us some semblance of what our battery state of charge is. And in addition to that, it is, of course, a BMS, right? BMS stands for Battery Management System. So this device is intended to communicate with our batteries and tell the other devices in the system what to do and when based on the data that the battery is sending to the BMS. So you have 3 devices in one and a very, very functional, very robust system here. So pretty excited about the next generation there. Now, the next product that we're going to jump over to is incredibly exciting and is going to offer you guys many new features and design capabilities as you look at operating in higher voltage systems and building out larger and larger systems. So we're actually going to jump over here to the NG battery line. So this is one of the first batteries in the NG battery line that we've been able to get our hands on. As you can tell, this is the 200 amp hour 24 volt. So you basically have roughly a 5 kilowatt battery sitting here. Now, the reason why this battery is relevant and the reason why Victron decided to launch this battery is because they wanted to give me and you more options and more usability as we design these larger and larger higher voltage systems. So this battery is going to allow us to build out a much larger system. You could actually use up to 50 total batteries in a system now in conjunction with a NG BMS. And this battery is now built in a cellular fashion, right? So if I were to pop the lid off of this, this battery's internals are now feeding data digitally over these M8 cables to the BMS so that we can see exactly what's happening inside of this battery. And so what that's going to allow the BMS to do is it's not only going to allow us to have more data, it's also going to allow this battery to function slightly better. It is going to balance better, and it is going to allow us to use a lot more of these in series or parallel. In addition to that, now that it is communicating digital information, right, zeros and ones as opposed to just analog information, it is now sending the BMS data that it can use to piece together a complete picture of the battery bank. So if I put 4 of these in series, the BMS is going to tell me you have 4 of that battery in series, and it is going to read, operate, charge, and discharge that battery as if it is that exact configuration. So we are gaining a ton of usability and a ton of visibility to this new infrastructure. And that's the primary reason why you would want to consider NG over the historical smart battery, is because you're going to gain all that digital information relayed to your BMS and all that control, right? So as we talked about previously on the, as we discussed the NG BMS, I can now see each individual cell, I can see the battery, and I can see all the information I would want to determine the health and function of this battery here on my screen or on VRM. So pretty incredible. In addition to that, they have added a few structural features that are new to the operating of the battery. Right, when you open this bad boy, you will discover that there are 2 metal feet that come out of the box. Just note that as you uncrate one of these larger batteries, they're pretty easy to miss. But they do come with these locking feet that you can bolt down to the ends, right? Make mounting the battery slightly easier. And beyond that, they also come with a sticker. All new Victron products that come in the new packaging, you'll find this little booklet. Okay, and this booklet has one piece of information in it that is incredibly critical, and you'll notice that there's a little phone symbol here next to that QR code. If you scan that QR code, you will be able to determine who you need to call in order to receive support on this product. So when you unbox a battery or a new Victron product, take that sticker, slap it on the side, somewhere that's going to be accessible in your application, and that will actually give your end user the ability to scan that very quickly and receive quick support. Prior to now, we all remember what it was like to operate in a 48-volt infrastructure using lots of wire, lots of Class T fuse holders, and all the other things that we went to in order to try and achieve a safe result. Victron's made it safer and simpler than ever for us to operate at these higher loads using these larger battery banks. If you guys need help designing a system or you have any questions, feel free to reach out.